Amanda, I wanted to make a video showing you the problems that you missed on the quiz, and I figured I could use this as a starting point to talk through some of the things that you had confusion on. The first one that you got wrong was where I gave you this graph of the cube root function. Remember that the cube root usually looks like this. So we had to decide how far it shifted. It went from here to here, which means that it went left 4. Now, big thing, anytime it's going left and right, that means it's going to be under the cube root sign with the x, which you had the idea of this one was your answer, this was the correct answer. However, the key is it's the opposite of what you would think. So usually I would think left 4 is minus 4, so I actually flip that sign to be plus 4. So it's actually the cube root of x plus 4 that moves it left 4. Okay, so under the radical is always left or right. If I would have added or put something outside of the radical, that moves it up or down, and that one's the same as what you think. Okay, so I'm going to use this to talk about the actual answer, the mistake you made, but then kind of extend it as well. Okay, now the reason that I wanted to talk about that is the next question talks about a horizontal stretch. Okay, and so this is another good example how we just said that if it was, and this was up here, but if it was under the radical with the x, it affected it left or right. In terms of translations, left and right is horizontal. And what that means is that anytime something is affecting the graph horizontally, it's going to happen under this radical, or if it was a problem that had parentheses, it would be inside the parentheses or whatever. It's grouped with the x if it's affecting it left and right or horizontally. Anything that happens on the end, this is going to affect it up and down like we said, but it's actually going to be vertically if we use that language. Now last but not least, we said in this case if it's moving it up or down, it moves it the same as what you would think, so what you see is what you get. However, when it was the left and right, it was the opposite of what you would think. So when you look at the number that's affecting the graph, you have to switch something in your mind if it's happening under the radical or inside the parentheses. What you learned in section 5, it must have been, is you started learning about stretching and shrinking. And if I think about stretching, I think bigger, so I would think my number is greater than 1. Whereas if I think about shrinking, I would think less than 1. The problem is if it's horizontal, that means it's going to be under the radical. And remember, we switch it. So because it says horizontal, I know it's going to be under the radical, but we say stretch. So usually I think bigger than 1. In this case, though, it's going to be less than 1. And anytime you're doing stretch or shrinks, whether they be horizontal or vertical, instead of adding and subtracting like we do in translations, you're going to be multiplying by something. Okay? And then it was translations that we did before, and that comes up over and over. That's when you add or subtract. So when I look at this, when you picked, you can see you picked D, the 3 is a stretch, but it's outside, which means it's a vertical stretch by 3. Okay, so it's not that one because it's outside. It also wouldn't be C because it's outside. So it's either going to be A or B because that 0.3, or the 3, is inside the radical being multiplied by the x. But remember, because it's a horizontal stretch, that means it's the opposite of what I think, which means I'm actually looking for the one that's less than 1. So it would be 0.3. Okay, so that moves it to the next one. The graph of 2.5x squared, or x cubed, sorry. It is in fact a horizontal compression. It's inside, so it's horizontal. It's greater than 1, which makes me think stretch, but it's the opposite, so it's a compression. Sorry, I was using shrink above. That's old school. But if I take a graph and I compress it horizontally, that means I push this side in and this side in. Which means it's actually getting closer to the y-axis. Okay, so this one was supposed to be y-axis. If you didn't watch the Play-Doh video that I put in the folder for this day, 10-5 day 1, I think, I encourage you to go back and look at that because Ms. Krupstadt, one of the intermediate algebra teachers, did a good job of giving you a visual of squeezing the Play-Doh and pulling it apart. Okay, so for the second one, you had g of x is 1/4 x. It's outside, so you're correct that it's vertical. The 1/4, I don't switch it in my mind. It is a compression because it's less than 1. But again, if I take that same graph and if I push down on it because I'm compressing it, it's going to get wider, but it actually pushes it towards the x-axis. Okay, so that was a smaller thing. If you didn't watch the Play-Doh video, that part would have been hard. So I do encourage you to go back and watch that. All right, next one. This is just a different notation to talk about it. It says, how does graph g of x equal f of k times x? So this is, again, it's inside with x. So anytime that happens, it's going to be horizontal, which it looks like you got. But if k is 5, I have to flip it. I see 5, I think stretch, but remember, because it's inside, it's the opposite, so it's actual horizontal compression. Okay, so you had the word horizontal right, but you did stretch. It should have been horizontal compression. And last but not least, this last one you actually had the right idea. Graph that is reflected, a reflection of f across the x-axis. You had this answer, which is actually okay, except it says simplify your answer, which means no parentheses. So this is the same as a -1 times x squared plus 3. Which means you needed to distribute the -1. So your final answer should have been -x squared minus 3. This would have been the answer you had to type in, and you can see that's what they had. So you had the right idea, you just didn't simplify it. That came up in your homework quite a bit. They weren't letting you answer like this. They would have made you switch it to that. So just make sure you get rid of parentheses by distributing the -1. Okay, so those are the things that you had wrong on the quiz, but bigger picture, again, instead of shrink, we use compression. Anything that happens with the x, so whether it be under a radical, inside parentheses, it's going to affect the graph left and right, which is horizontal, and you have to switch it in your mind. So if it's an adding or subtracting, you do the opposite symbol, and if it's multiplication, you actually, if it's greater than 1, it actually is a compression. So that was probably the biggest thing. Anything that happens on the end does affect it vertically, or if it's multiplied in front, that's also vertical. And again, it's as you would think. So if it's a number bigger than 1, it's a vertical stretch. If it's smaller than 1, it's a vertical shrink. Okay, let me know if you have follow-up questions. Thanks, and hope you're doing well.